The aim of this session is to introduce you to the field of data analytics and explain what we're offering as WithYouWithMe to veterans to break into this field. And it's also going to highlight why veterans are suited to data analytics in general. And I'm also going to show you a piece of the course so you get a feel for it and also see how we're approaching this slightly differently to other offerings. So I'll talk through a bit about the data analytics environment first, and then I'll talk about the data analytics pathway. So if you know about WithYouWithMe, you know that we've made a lot of ground in cyber and robotics process automation. Data analytics is a new pathway, and there's a lot of opportunities coming up in that field. So I'll be talking to you about visualization and misleading statistics. Okay, so why data analytics? So there's 4 major factors that have contributed to the environment today in which we require so many data scientists, analytics, and engineers. The first thing is data collection. From the invention of writing until the present, it's estimated that we collected 5 exabytes of data. So from 2013 till now, we collect that amount of data every day. So to put that in perspective, the reason that's been enabled is by data storage, cheap data storage. So in 1967, 1 megabyte of data would cost $1 million on a hard drive disk, and now the comparative cost is about 2 cents. So it's a very short window of time that this has increased. Processing power, an Apple iPhone 5, it's 2.7 times faster, has a faster processing speed than the fastest supercomputer in 1985, which is the Cray 2 supercomputer. And then statistical and programmatic methods. We're kind of standing on the shoulders of giants here. Much of the statistics that we use were developed over a century ago, but it's not just that, it's the invention of machine learning and programmatic methods that allow us to process a large amount of data. So what is data analytics? If you just do a Google search, you'll find that it's not very well defined. And that's because a data analyst in a small company could be doing everything from the collection of data through to the analyzing it to communicating it. But in a large company, it'll be fit somewhere in the pyramid. And so it'll just be doing a specific part of the pipeline. But generally, we can say that data analytics is transforming raw data into insights which enable decision making or increase understanding. So to break that down, transforming raw data, we're talking about extracting it and using some form of programming language to transform it in general. It doesn't have to be a programming language. In fact, many tools can cover off on that as well. But the main one that you might use is structured query language to do that. It's also the most complicated and technical part of the role. So actually up to 80% of your time as a data scientist or data analyst is spent in that first stage, getting the data to a position where it's actually ready to be analyzed. And then turning them into an insight sounds easier than it actually is, because an insight has to meet a few conditions. It can't be something obvious that someone could just find with a few drags of a few drops. And it has to actually provide value to a business need. And it has to arrive in time for it to be actioned. And all these things have to be met for it to be an insight. So if you think about the sort of person that's going to find an insight, you think that it's not just about the technical skills, it's about the person that's being able to understand the problem and then finding an appropriate solution. So a business analyst and a data analyst are similar in a lot of ways. The real difference is the technical capability of a data analyst and some of the statistical methods that they might use. There needs to be a reason. So it needs to enable decisions, or it needs to increase understanding. You can't always enable a decision. That's very difficult to do, in fact. So if not enabling a decision, it has to increase the understanding of a decision maker so that they understand what's happening with their business or whatever the problem is. So in the course, we break this down, the process down into 4 distinct elements: defining the problem, transforming the data, analyzing it, and then communicating it. It's overly simplistic for a reason. The reason is people get very lost in the process and they get completely wound up doing just one part of this process. But you have to keep in mind that there's always a reason why you're doing the analysis, and that the analysis, for the sake of analysis, is pretty useless. So the key thing that we're doing here, the way that what makes us different from other online course providers is that they tend to teach tools, so they teach you software. So they're saying if you know this software or if you know this tool, you'll be a good data analyst. And that's flawed because you can be great at structured query language, or you could be an expert in Tableau or Power BI, and you can still be a pretty poor analyst if you don't understand the business need and you can't communicate your problem, right? The difference is what we're teaching here is the center bit, the skills, because the skills will give you targeted proficiency in these tools. The tools that you actually need to know. These are just tools in your toolbox, and you delve into them when you actually need to, when it's most applicable to use. And the other thing to realize is a lot of focus is on coding languages like Python or R. And we think if you don't know these coding languages, then you're not a data analyst, you're not a data scientist. But if you think about anyone, I think quite a few people here from IT background, if you do anything on any interface, if you're clicking buttons, in the background what's happening? Code, right? You're creating code, whether you're doing it for an interface or if you type it manually. So if you're typing it manually, there needs to be a reason. And the reason is that you can be very specific with what you're doing with that code. So that means that you don't always have to code. It's just that you use it when you really need it. It's a tool in your toolbox. So that's the real difference here. We're taking people on the left, veterans, with attributes on the left, people that are suited to the role. We're teaching them skills on the middle, and in the process of learning the tools. But we're not approaching it from right to left. So the actual course, so the course it's a 12-week course. The aim is for you to dedicate between 4 to 10 hours a week. It just depends on your prior experience as to how much you'd actually have to contribute. But effectively what it's covering is exploratory and explanatory analysis. You'll be building data models, and then you'll be taking that through to visualization and the creation of dashboards, which are interactive graphical user faces, and then to presentation. The statistics that you're using, it's not that far off what you learned at school. You're just learning how to use it properly. So it's not about whoever uses the most complicated statistical method wins. That doesn't matter to the person on the other end. What matters is that you're actually solving a business problem. And these are the tools that you'll be using. So it's advanced Excel, so you'll be using Microsoft Power Query, and that links into Microsoft Power BI, which is actually a very powerful tool. It's the competitor to Tableau, which is a visualization tool. But Microsoft Power BI has the ability for you to script with R or Python inside of it. So it's a good introduction to R and Python within Power BI. So post this course finishes on the 7th of November. The next one, I have to say, is in January next year. We'll be delivering a structured query language course, which is the coding language that we use to interact with databases. I have a mentor who is currently a senior Facebook analyst, so I'll be developing the course. It's currently under development, so I'll be developing that course with him. And the main aim for it is to be able to extract data and transform it from relational databases. And also, some programs such as Tableau allow you to code in SQL in the background as well. So it has wider applications. A study of data scientists' job applications in the US said that SQL was the #1 listed skill. It's definitely a differentiator at a job interview. Whether you actually use it in the role, though, on a daily basis is not necessarily the case, but it's what people are asking for. So this is just a little bit of a quiz. So this is a question for you. So I just want you to have a look at these 3 profiles and think about who you think is the ideal profile for data analytics. So on the right, you have John, the technical expert. This person prefers not to speak to people or communicate. They deliver really perfect product, and they love proving other people wrong. They absolutely love maths, and they're a maths genius, and they're pretty process driven. They're like step A to step B to step C to step D. That's John. And then on the left, you've got Peter. He's highly creative, doesn't really like numbers, very people focused, loves presenting, and gets pretty easily bored. And then you've got the center, you've got someone who's an all-rounder. They like getting to the root of the problem. They like working in a team. They learn new tools pretty quickly, and they have an aptitude for languages. So I want you to have a think about who you think the ideal veteran profile is for data analytics. And if you're on the live stream, then just like comment that in, please. And for you guys, like I'll just ask you a bit later. So now I'm just going to go and, in fact, I'll probably pause here to see, is there any questions on the course offerings that we're providing here? I'm about to preview a bit of the course so you get like a feel for it. But hopefully that has explained like how we're approaching the actual course and maybe what we offer. You guys got anything? No, good? Sweet. All right, so we're going to talk through visualization. So you'd be mistaken for thinking that visualization is just a way of making data look pretty, because it's actually far more important than that. So visualization actually changes the way we humans absorb data. So it takes advantage of our spatial memory, and it really helps us understand the underlying data. So I'll take you through how that works. So a key element is something called pre-attentive features. These are features processed in our spatial memory, and they're processed in less than 500 milliseconds. And we use these features in visualization to draw attention to the most important parts of our visualization. So here's the majority of pre-attentive features. And if you're in the military, you can maybe remember when you learned about like how to camouflage things. These are the things that attract people's attention without them even thinking about it. It's like size, color, and then all these other things, width, curvature, etc. So I'll give you a bit of a demonstration. So the task here is to count the number of threes in this 10 by 10 grid. And yeah, that's going to take you a bit of time. There's actually 13 threes, but what about now? So the threes are in red, and the other numbers are in gray, and that's a pre-attentive feature color, and you can see how much easier that makes things. Now, in this case, color is still being used, but the other numbers are in dark blue. So it's not just using color, it's the actual combinations of color and the hue that matters. And then finally, I can show you what happens if we make the threes bigger. That's another pre-attentive feature. It's just to demonstrate to you, nothing has changed about these numbers apart from these features, but it really helps you draw your eye. So now that we know about pre-attentive features, we should just load our visualizations with as many as possible. That would be no, because what happens when we have too much information to process in our spatial memory, we get something called cognitive overload. That's where the effort required to process something outweighs the cost. The processing power outweighs the cost. So like if you're in a presentation and you see that really busy slide, and you just go, nah, I'm not even going to try. That is cognitive overload. It's not that you can't process that slide if you really wanted to. It's just that the effort required is not worth it for your brain. That is what we're trying to avoid. So when we use pre-attentive features, we're using them sparingly, and we're using them to highlight the most important parts of our visualization. If we use too many of them, the eye literally cannot make sense of it, and we just hit cognitive overload. So when you're building visualizations, it's helpful to look at things as to who, what, and how. So who's your audience? So if you're presenting to a senior manager, they may be used to receiving the raw numbers. So if you're going to present them a visualization, maybe not the most complex visualization, and maybe you want to ease them in. But other people actually hate seeing the raw numbers, and in which case you want to tailor your visualization to them. What do you actually want them to know? What do you want them to take away from your visualization? Sometimes we just build visualizations just because they look good or because they're interesting. But what do you actually want your audience to take away from it? What's the one thing that you want them to take away? That just makes sure that your visualization has a purpose. And then how? So it might show off your skills to produce a really complicated graph, but it's actually the best way to get your message across. Maybe it's better to have 10 graphs that build upon one another and build a story. Maybe that's actually the most responsible thing to do, because you actually do have a responsibility to present your visualizations in context, so that they understand how you got there and not just the end result. So there's two things to get right in your visualizations: color and clutter. So we want to use color effectively, and we want to avoid the use of clutter. So let's look at color. Color is probably the most powerful pre-attentive feature, and it also sparks some psychological reactions as well. For example, red with danger. That means that using too many colors or using the wrong type of colors can really take away from what your visualization is trying to show. So you should use color to either distinguish one variable from another or to tie variables together when they're on a dashboard. And you can also use it to draw attention to a particular element of your visualization. So how? Generally, avoid using highly saturated colors. Highly saturated, we're talking basically bright colors, because the eye is drawn to the different competing colors, and it can't actually make sense of the overall visualization. But and there are some low saturated color palettes that you can look up. So there's a website called Color Guru, which actually offers some good samples. But most tools have low saturated colors on offer. They're generally not the first one that comes up though. You have to change the colors and the settings to get the better options. And then clutter. So clutter is something that's unnecessary in your visualization, but it's not something that may have no value at all. It's just not worth the space. So for example, you might have an axis title, but if the axis is obvious, if it's time, for example, that's an unnecessary piece of your visualization, and it's taking up processing power. So we want to avoid clutter where possible. I'll just give you two examples that should put this into context. So here's an example of a bad visualization. The reason that it's bad, does anyone want to have a go?
Too many colours?
Yeah. What else about the colours?
It's not clear in what it's trying to define or what you're trying to say. There's just too much going on.
Yeah.
Some of them are obscuring the writing is so bright.
Mm-hmm. The other thing is that, yeah, come in, please. Yeah.
And the distinction between the groupings is a lot harder to read than the numbers.
Yeah,
So defining what that square is about. Yeah.
Yeah, the other key thing is that they're using different color scales to define things. So on the bottom left here, they've got a red through a green color scale, with green is high and red is low. But so yeah, guys, we're going through just a sample of the course. We're talking through visualization, and then here we've got color scales of dark green through to light green. So it's confusing because the greens are used in a different way for both of those. And then, yeah, there's just too many colors around. So this is a good example. Even though these train lines have colors associated to them, perhaps it's not necessary to have the colors on show because people can still read what the line is. The other thing is, as you mentioned, clutter. There's just too much information on this dashboard, and some of the information is definitely unnecessary. Like for example, how well can you actually read this article on the bottom left? Perhaps it's better just to have some other form of link rather than that as an example. So this is a good visualization. So this was a winner of a Tableau visualization contest. So what's good about this visualization?
It's clear. It's got everything that you want to see. It draws the attention to exactly what the user is viewing. Uses color scale to sort of see what's bad, what's good.
Yeah, that's exactly right. Yeah, so the highly saturated colors on show are drawing you to the most important parts of the graph. So this is showing you how much older you are than the American population. So your age is being highlighted by the color, and then your actual age is the same color, so it's tying it together. The different features are being tied together. This is a low saturated color palette that's on show here, and there's just nothing about this visualization that's unnecessary. Every part of it has a purpose. So in the course I go through specific types of visualizations, but there is actually some things that you should avoid. and one of them is pie charts. And that's because we as humans don't process angles very well. That then makes it hard for us to understand the proportion of a slice to the whole. And then 3D charts, they distort our understanding of proportions. So that's an example on the left of both. And it's really hard to actually tell what slice proportion each product represents. But then in the bar chart on the right, it's far easier to actually see. Doesn't mean you can't use pie charts. You just have to be careful about how you use them. So maybe there's only 2 variables in the pie chart. So you're showing that there's a point that you're trying to make, and the point is that 80% is one variable and 20% is the other. Well, the pie chart's probably good enough for that. But if you're trying to show 5 or 6 things, then definitely avoid. So that's the first showcase. How are we doing for time? What's the...
37.
So yes? What's up?
So it's going to be 5 to 6.
Oh, 5 to 6, cool, all right. So, misleading statistics. So there's 2 things that I think break people's faith in data analytics. One of them is being on the end of misleading visualization statistics. And the other one is hard to understand visualizations. So these are the 2 things that people just go, when people say, statistics can tell you anything, it's because they've had a bad experience in the past. They've been presented information in a disproportionate way, and they've been misled with the use of statistics. Because statistics don't actually lie, but they do tell a lie if they're used incorrectly. So this is about understanding some ways that statistics are used misleadingly, whether on purpose or not, and then how to avoid them. So the first thing is, well, here we have a column chart, and it's showing US GDP growth from 2016 to 2018. And in January 17, President Trump takes office, and the Republicans actually make a lot of fuss about how well the economy is doing under President Trump. Now, can anyone see what's wrong with this graph?
It's just the rate of growth.
It just gives the 3%, the full scale, not give that.
Yeah, so the axis is actually starting at 1.4%,
Yes.
and that actually skews these columns. And it sounds like something that people wouldn't do, but it is actually something that the media has been caught out on in the past. Media being very broad, and it's actually something that people do sometimes, and they don't explain it. So that's one way that visualizations can be misleading. So that's what it actually looks like with the axes set to 0. So it's just something that you can do, is just check that the axes are set to 0. If an axis isn't included, ask that question to yourself, is this graph in proportion? And if you are going to set the axis to something other than 0, just be very clear, because there are reasons that you need to do it, but just make sure that your audience understand. So the second thing is presenting things out of context. So why are they only showing the GDP growth in the year before and the year after Trump was elected? When you look at GDP growth that includes Obama's 9-year term, then you can see that in 2015, GDP growth was 2.9%, the same as it was the year after Trump's election. And that actually there's what appears to be a pattern here that's being almost repeated between 13 and 15 and 16 and 18. So we should always present our data in context. It's not always possible to show the full context, but it's important that if we're presenting data that we list assumptions and explain the context before we go and delve deeply into observation. So the third thing is failing to normalize your data. So here's company X, and they've had 350 males leave their organization in 16-17, and 200 females. So the deduction that people are making is that male retention is worse because more men have left. But that's actually a pretty obviously incorrect way of looking at it, because what we need to find is how many men work in this company in total. And by doing that, we can see only 26% resigned versus 35% of the 450 females that work at company X. So if we use that normalized figure, then the graph would actually look like this. And by normalize, we mean bring data points into common measurements so they can be compared. So misrepresentation number 4 is the percentage difference versus percentage points. So we're back to our graph. This is GDP growth. And the Republicans are making a big deal of the 2000, this is obviously theoretical, of the 2017 to 2018 difference in growth. So they're reporting that the GDP growth has increased 20%. And that's correct, it has increased 20%. It's increased by half a percentage point, and that is 20% of 2.4%. So the percentage increase is 20%. The Democrats are trying to downplay the growth, and they report that GDP growth has increased by 0.5%, or half a percentage point. They're both reporting accurate facts, or statistics, but one of them sounds a lot worse. So what you can do is, if you're going to provide one, then try to provide the other, or provide the raw data so people can see that themselves, and just present things in context. And then the final thing is correlation is not causation. So you would have heard that. It's a very common saying. What do we mean by correlation? We're talking about how two variables are related to one another. So how much of an increase in one is seen in the other. So for example, height is generally correlated with weight. The higher the people, the taller the people are, the more that they weigh. That is useful information. It's telling us that if someone is tall, they probably weigh more. But it's very different to saying that the reason that someone is tall is because they weigh more. That's causation. So correlation versus causation. But the point I want to make is that people often band that around to say something bad about correlation. Correlation is actually really, really useful. Just because it isn't causation doesn't mean that it's not useful. So often you'll hear people use it as a term to dismiss a piece of analysis. They'll say correlation isn't causation. But correlation is showing us that these variables are related. It can lead us down a path where we try to prove causation with a controlled study, or it can simply indicate to us another variable that's responsible for both of that relationship. So correlation is really important. Actually, the biggest misrepresentation is where people say it and they don't actually understand what it means. So I'll conclude here. So the things I want to get across is that the field of data analytics is growing. The actual skill of data analytics has been around since the dawn of writing, but the field of what we know as data analytics is growing. We're offering veterans free training to break into this field, but we're trying to build the squad model, which we've already implemented with cyber and robotics process automation. So the next step for this pathway will be the delivery of squads made up of veterans into companies on a sort of consulting basis. We're going to come back to that, the veteran profile thing. The point that I'm trying to make with this is that there's a lot of Johns in the field right now. The technical experts, they're perfectionists and they're process driven. And their main aim is to prove someone wrong. They want to prove someone wrong because they're the expert, but actually the field isn't quite like that. It's very difficult to prove anything in data science. You're not proving anything, you're making inferences, which means that someone that likes to have a black and white approach to everything isn't necessarily the best person, but there's definitely a large place for that person as well. The point is that Sandy, with her ability to learn new skills quickly and to communicate the results, is going to be a real asset to a team from a data analytics point of view. And the process of getting a Peter to become a Sandy by teaching a Peter technical skills, it's the same. It's almost as hard as getting John to come out and present in front of a group of people. It's just a different approach of looking at data analytics and the sort of reasons why veterans be suited, because veterans have to have quite a few of Sandy's attributes as part of their job. So we're taking people that already have a lot to offer and teaching them technical skills.